Put all the things on all the tracks in all the things. Hello. If you can hear me, say something. If you can't hear me, also say something. We've been having fun and games here at haha, marvelous. So I'm a big fan of software that has a dialogue, that has a simple mode and an advanced mode. And if you switch it into advanced mode and you mess with it and then you switch it back to simple mode, all of the advanced settings remain there. They stay the way you set them. It's just they're invisible now. Yes, hey, Dominican Republic! Fantastic! Welcome! So there used to be this lovely. The reason I know the Dominican Republic, there used to be this fantastic thing we did in school where you kind of get someone to think of a number and multiply it by their age and subtract something and something, and then you go, right, now subtract the number, and eventually you go, right, now I want you to think of an animal. If A is 1, B is 2, C is 3, D is 4, E is 5, and the way the maths worked on it, they'd always end up with 4. And then you'd say, I want you to think of a country that begins with your letter of the alphabet, and they'd always go for Denmark because no one ever remembered Dominican Republic. And then you'd say, now think of an animal beginning with the second letter, and now think of what color that animal might be, and then you'd say gray, and they'd be like, and you'd be like, grey elephant from Denmark, and they'd be like, yeah, magic. That's what passed for entertainment in the schoolyards of, actually Zimbabwe is where I first learned that one. That's where I went to school years ago. Anyway, welcome, friends, to Advent of Code Day, what day is today? Day 9. It's a very exciting day because immediately after I've beamed to Dominican Republic and Nottingham and all of the other places where you're all streaming in from, I'm going to readjust my little study here, and then I'm going to beam myself to, where am I going later? I think Munich, virtually, to do a keynote talk at an InnoQ technology event they got going there, which is cool because it's all about algorithms and creativity and cyborg chess or centaur chess. You heard of this thing? It's a... Gary Kasparov is like the world chess champion for years and years and years. He's the guy who finally lost to Deep Blue when he was the world champion, #1 rated chess grandmaster. And Kasparov lost to Deep Blue, which was IBM's supercomputer, and basically that's kind of it. Like, that's it. Now computers are better than people. And today, Magnus Carlsen, who's the world chess champion, just says he doesn't bother playing computer chess because they win all the time. But there's a thing called centaur chess, which is basically freestyle. It's human plus computer. So you can use your computer to help you be better at chess. And it turns out that a reasonably good chess player with a reasonably good computer can actually beat grandmasters and supercomputers, which I just think is awesome and fascinating and brilliant. So I'm going to be talking about that later, but now we are talking about Advent of Code. So welcome. We are going to look at day 9. Encoding error. So far today in Advent of Code, we have, do you see the thing on Reddit, are we the baddies? It's like, day 1 we had the thing with stars, on day 2 we knocked over a whole bunch of trees with our toboggans, on day 3 or day 4 we had to hack a airline to get on a plane with a false passport, and then day 5 we had to steal some boarding passes, and day 6 we were spoofing landing forms, and it's what is the end game here? How's this going to play out? But I'm assuming because we are one of the Christmas elves, we are on the side of good. Maybe chaotic good, but we are definitely on the side of good. So, day 9, encoding error. With your neighbor happily enjoying their video game that we fixed yesterday by brute forcing every possible combination of instruction mutations, you turn your attention to an open data port on the little screen on the seat in front of you. The port is non-standard. You have to connect it to your computer through the clever use of several paper clips. Upon connection, the port outputs a series of numbers. The data appears to be encrypted with the exchange masking addition system, which conveniently for you is an old cipher with an important weakness. Xmas starts with a preamble of 25 numbers. After that, each number should be the sum of any 2 of the 25 immediately previous. The 2 numbers will have different values. There might be more than one such pair. So, for example, suppose your preamble consists of 1 through 25. In order to be valid, the next number must be the sum of 2 of those numbers. All right. So, yeah, that's fine. 49 is fine. 100, yep, can't make that. 50, yeah, so you can't add 25 plus 25. It's got to be 25 plus something else to make that number. Okay, 26 number. The first number is no longer an option. Okay, so we got a kind of sliding window of 25 numbers in our sequence. 26 would still be next. Here's a larger example. Okay, so this is a preamble of length 5. And in this example, after the 5-number preamble, the only number that does not follow the rule is 127. So 1, 2, 3, 4, 5 numbers. 40 is valid there because 40 is 15 plus 25. Okay, our new window is those 5 numbers. 62 is valid because it is 15 plus 47. Okay, our window is now those 5 numbers. 55 is valid because it is 40 plus 15. Move the window. Our window 65 is valid because it is 40 plus 25. Move the window. 95 is valid because it is 55 plus 40. Move the window. 95 plus 40, yep, okay, 102. So 102 there is, 62 plus 40. Move the window. Okay, so you see how the thing is going to play out. We're going to be looking at it. For any number, we want to take what we will call the preamble to that number. And because our test data here is length 5, but the actual assignment is length 25, it's going to make sense to allow us to specify the size of the preamble that's used in our encoding system. We got to look through a bunch of inputs, and we've got to find the first number, which is not the sum of 2 numbers from its preamble. Right, as discussed yesterday, we are optimizing for fun. We are not optimizing for performance. We are not optimizing for maintainability. We are not optimizing for minimum number of instructions or readability. We're optimizing for how much fun we can have writing code to solve Advent of Code Day 9. So let's fire up the Visual Studio. And we are going to create a new project, which we are going to call Day 9 Code. Command line console app.NET Core. Next on that one. Oop, hello. I got this little thing on my screen which pops up sometimes, and that's some kind of smart AI app, but it's actually just a control panel for fans. But it's called Smart AI because everything sounds cooler if you put AI at the end of it. This is Day 9 Code. It is going in D Projects GitHub Advent of Code 2020, and it is going in a solution called Day 9. Boom! There we go. Can you optimize for brute force? Like, surely at that point, so Arias just says in the chat, optimizing for brute force. Is that just like randomly solving things that don't need solving? So there is actually an I is an animal. It's one of the 63 allowable 2-letter words in Scrabble, AI. It's a type of sloth with 2 toes that lives in Brazil. There's also an animal called an ai, which is a lemur that lives in Madagascar. Because there was an old QI question, what's the difference between an I and an ai? So a smart AI could just be a very, very clever sloth who lives in the Amazon rainforest somewhere. And then you got the Amazon angle. So Amazon AI, everyone's like, ooh, we'll invest in that. And it turns out to be a very, very dim-witted creature falling off a branch. Sloths sometimes fall out of trees because they grab their own arm like this, thinking it's a tree branch, and then they let go with that one, and they fall out of the tree. They're brilliant animals. Right, anyway, let's get back to the serious business at hand. We got a set of inputs here, so we are looking for this set of numbers here. And for that one, if we have a preamble window of 5, we are looking for the first number that does not add up to a sum of any 2 inputs. So static string input equals, we're going to plug in that list of numbers there. So again, I think most of the programming here, I think we're going to have more code to read the input and turn it into numbers than we are going to have to actually solve the problem here, because I have a fun little idea here. Maybe. So, what are these things? These are just numbers, aren't they? They don't have a name. It's just numbers. So let's plug in. We got a bunch of things there. 35, 20, 15, 75. Save that. So var numbers equals input dot split on. Let's play the old Advent of Code donkey sanitizer. Input dot replace carriage returns with nothing. dot select, input goes to input dot trim. Check your real input, they get big. Ooh, ooh, how big? Ooh, this could be exciting. Them are some real crunchy numbers. And they're in order, aren't they? So the biggest one is the end. So the biggest number is that one. So how big is that number? That is... So int32.max value is 2 billion and something. So int64.max value, otherwise we're looking at arbitrary precision arithmetic, which is a little bit hardcore for day 9 of advent of code. Let's have a look. int64.max value is that. And that relative to that. This is some really serious arithmetic based on, is this number longer than that number? Okay, let me check it int32.max value, which I think is too small to hold my largest input here. Yes, it is. All right, thank you for the heads up there, Matthew. Yeah, all right, we got crunchy inputs. So input, replace on that, select line, goes to line.trim. Why is that complaining? Because input doesn't mean anything yet. String input equals, yep, that's fine, that's fine, that's fine, that's fine. Replace that, select those from... I need to split at this point, don't I? Dot split on that, dot select that, and I need to remove entry empty entries. String split options dot remove entry entries. You know what I'm gonna do? I'm gonna do a thing. I know a thing later. So like line trim dot select line goes to int64 dot parse line. Have any of you ever heard of a thing called DEX64 arithmetic? It's created or popularized by Douglas Crockford, the guy who invented JSON and wrote JavaScript, the good parts. And DEX64 is brilliant. It's go and look it up at dex64.org or whatever the web address is. It's basically a 64-bit field used to store numbers with a radix and a precision that will allow you to... I worked it out once. It'll allow you to measure the distance from here to any point on the surface of Jupiter down to, I think, 1/10 of a millimeter precision. And it's just a really, really clever input format. It solves all the problems of floating point imprecision and that kind of stuff. That replaced that. Okay, that's fine. int64.parse. Boom. So now we got a big fat list, and we are going to want to list that, I think. And then we are going to do a fun little thing here. I'm going to put a static class link extensions. And I am going to put on this a public static. This is going to be an int, because an int is what we're looking for. It's a big int. So what is it, int64 in C? I'm going to just use int64. C# and .NET have this kind of weird thing where C# the language has a bunch of types, and .NET the runtime has a bunch of types. And so an int64 with a big I like that in C# is equivalent to either a long, I think it's a long so that's a .NET type, and C# has a long type, and the compiler mediates between them. But once you get into doing 64-bit stuff, it's easier to use the big names instead of the little names, even though it means the same thing. Public seg int64 find anomaly, weirdness. I can't spell anomaly. We're going to call it weirdness instead, because I know how to spell that. This list of int 64 inputs, and we are going to take an int. Now I'm assuming the size of the preamble is never going to be a 64-bit number. I think that is a safe assumption to make, given we've got one that's 5 and one that's 25, and we are unlikely to encounter any others. So what we want to do is, first of all, we need to This is going to be interesting. So we want to look at the, so first of all, if inputs.count is less than preamble size, bail out. Just return, what, 0, I guess. Return -1. There we go, that's our degenerate, that's our error code. So if not, then we want to say, now we could just do this with a kind of weird loop. Let me try something here. It could be kind of fun. So I'm going to say inputs.skip preamble size. So that's going to jump over the whole of the first whatnot. So this is now going to give us an enumerable that starts at position, say, 26. And I want to find the first number in that sequence such that the... this is where it gets a little bit interesting. We maybe need to do this as a loop. X goes to... Yeah, let's try doing it. Let's try looping it, and then we'll see if we can flatten it down later. So let's say a for var I index equals preamble size plus 1. I is less than inputs.count I plus plus. I less than inputs.count I plus plus. So we're going to basically go, if we got our list of numbers 1, 2, 3, 4, 5, 6, we're going to go, okay, from 6 to 7 to 8 and enumerate along the list that way. And we're going to do it by index, which means, yeah, that is a list, so it is addressable by that. We want to say if so we want some property on here that just says if inputs.isWeird. We'll get that in a second. I preamble size return I. Easy. So look through all the numbers, and if you find a number that's weird, give back the weird number. Now all we need to do is define what do we mean by weird. So we can throw in that on here. Public static bool is weird. And this is again going to be an extension method of this list of int 64 ints and int index, int preamble size. So we are gonna say list int 64. I can make these generic actually, can't I? I can just make that list of t and that list of t. Capital I on isWeird, inputs.isWeird. Yeah, because it's public at the moment. So that's fine, that's fine, that's fine, that's fine. This list of t, that's going to return a t, that's going to return a t. Find weirdness, this list of t using, okay, we'll get that in a second. Should be alright, should be alright, should be alright. So we're going to say list preamble. So what we want is a window onto our input that gives us the range of numbers that must be taken into account by this number, which will be ints dot. So the first one we need to skip at is 1, 2, 3, 4, 5, 6. So hang on a second, let me think this through a second. So what we got to do here is we got a list of elements here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, boom, boom. So indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Preamble in this example equals, let's say, 5. Let me zoom that in a little bit. Hang on. There we go. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Our preamble here is 5, which means if we are looking at that one there, index is equal to 7. And the window we need to look at is 1, 2, 3, 4, 5 of those. So that is our preamble there. which means we need ints.skip 2, 1, 2. So we want to jump over those two, and the relationship here is that 7 minus 5. Yeah, so index minus preamble gives us the skip. Index.skip, back to the code, index minus preamble. Maybe only pass the chunk of preamble size to is weird and the number which is the sum of two of them. Redness on line 40. So that's it's complaining because I don't always return anything. But we'll get to it. I'm quite good at ignoring red while I'm still thinking through what it is that I'm trying to do. Yes, that needs to be a yes. Of course it is, because the methods need to at least be told they're generic methods, even though we're not going to have to specify a type parameter when we actually need to work on them. So inst.skip that .take preamble size .first. Now we can do an interesting thing. If you remember earlier in the whole so that's an IEnumerable of preamble. That gives us the set of numbers we're looking at. So we will now want to say, yeah, that's fine. From so we got a thing we can do using link where we can say from foo in ints. Let me just open this up a second, because I've got here in the solutions that we did earlier in the week. I think it was day 1, had quite a nice solution from my friend Nick. Yeah, that was it. That was the syntax we wanted. This thing here, from x in ints, from y in ints, from z in ints, where something equals something. So we want to do this. Var, so what do we got here? X, Y, Z, select x times y times z. So var sum equals from a in preamble, from b in preamble. The numbers are always unique, aren't they? We're not going to get the same number appearing twice. What's the emoji, Surly? It's come up very, very small in my restream chat here, so I'm not entirely sure what it is. So where a is not equal to b, and that should be fine. From a in preamble or b in preamble, where a is not equal to b, and a plus b equals, we're looking for, what are we looking for here? We're looking for the target. So t target equals ints at index is correct. That should be fine. It's called Seems Good on Twitch. It's a bloke sticking his thumb up. All right, I can live with that. Typo in identifier ints, I don't care. That's fine. That's all right. Null code pass return a value. And a plus b equals target. So from a in preamble, from b in preamble, where a not equal to b, and cannot apply. Okay. So we're getting some fun and games here. So you see the error that's popped up there. Cannot apply operator to operands of type t and t. Because we're being generic, all kinds of stuff is going to stop being weird, and because we are not actually gonna need the generic capability, I'm gonna bake this back to being an int64. So that's fine. That's fine. That's take that out. Take that out. Take that out. That is a list of int64 inputs. Inputs.is weird. That is a list of that. That is int64. That which can be varred. Thank you. Can be longed. Interesting. It can be varred. Okay, that's cool. IEnumerable of, so that can just be a var as well. It'll infer the type for that. From a in preamble, from b in preamble, where a is not equal to b and a plus b equals target. Return. So what is it we just want? We want the sum, but we might not have anything in there. So what we can actually do here is we can say select, I think it's select, yeah, select 1. That probably needs to be like that. Dot first or default. So this thing, if it finds anything, it's going to give us 1. And if it doesn't find anything, it's going to give us if sum equals default of int, then at that point we are going to return, that means that that number was weird. So return sum equals default int. Oh, that's nice. That's another new C# thing. You don't need to tell it what kind of default it is because it can infer it from the fact that sum is an int. So that's fine. So we can take the parentheses off there. So what this is going to do, yeah, that's a multiple enumeration, which should be all right. It won't be a problem in this scenario, is we're going to say, look in the list of ints, skip that many so we get a preamble that's relative to the same number, and then from A and B in preamble, if A is different to B, because we can't count the same number twice, and A plus B equals the target, so they add up to give us the sum, then select 1, and that thing is going to give us back a 1, or it is going to give us back a nothing. It's going to give us back a default. And if we get a default, then boom, it means we didn't find any. And if we get a 1, it means we found one. So that's fine, that's fine. Input is weird, I in preamble size, return I, that's fine. So we should now, that's all right, that's nice. Let's see what we get. So there's our numbers, and we want to, that is looking for, that's going to return the index. And we want the number, don't we? We want the first number in the list, which is weird. So return inputs I. So let's just double check the requirements before we YOLO this thing into low Earth orbit. YOLO, yeah, all right. Advent of code 2020, there we go. Day 9. So here is a larger example. That's fine. That's fine. The only number is 127. So we are looking for 127. That is the answer that we are expecting to get back from this set of test input. Var YOLO equals numbers dot find weirdness, and our preamble size here is 5. Console.writeLine YOLO. What do we got? Why is that complaining? It's not. It's happy. It just doesn't like the word YOLO. Let's see what we can see. You ready? Boom. Run it. 127. Sweet. Okay, so based on that exhaustive testing across multiple platforms with stakeholders and users alike, let's bung the real input in and see what we get out the other side. Get your puzzle input. Right-click, save as. Ooh, hang on. Oh, that's right. No, these numbers are not in ascending order. Even though they do get bigger, they don't. Yeah, okay. I don't think that matters. Does that matter? No, it doesn't. It's just a sliding preamble, isn't it? Yeah, okay. That should be fine, he says, with all the confidence of somebody who knows that this doesn't really matter very much. Day 9 code, input.txt, boom, save, right-click, Solution Explorer, input properties, copy to output directory, copy always, rebuild the whole thing. And at this point, we want that input is no longer required. And let input equals file.read all text input.txt. Let is a JavaScript thing. It is not going to work in .NET. Okay, hit it. Run it. Boom. 16. I haven't changed the window size, have I? I was going to say 16. That looks a little optimistic. Boom. 2, 2, 4, 7, 6, 2, 4. Copy that. And is that going to work when we plug it into Advent of Code Day 1? Right click, paste. What do you think? Boom, it is correct answer. 1631. Damn. 31 minutes for part 1. But I told the story about the Dominican Republic and the elephant and all that kind of stuff, so maybe we should start the stopwatch after the banter has finished. What's part 2? The final step in breaking the Christmas XMAS encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers which sum to the invalid number from step 1. Contiguous set of at least 2 numbers. So that's all fine. That's all fine. So we're looking for a series of numbers that adds up to give us the number we just found. So what do we need to do here? We need to... we got the YOLO equals fine. Well, let's rename that to be... what did they call it over here? Invalid number. All right, we'll call it that. And then we need a sequence in here, so you must find a contiguous set of at least 2 numbers. They don't give that thing a name, do they? They just call it contiguous set. To find the weakness, add together the smallest and largest. So I'm gonna find, we want to look through this, and we're going to find a series of numbers that add up to give us the number that we just thought of. So var sequence equals numbers dot find contiguous list of more than 2 numbers that adds up to invalid number. I like that. That's a good method name. It says exactly what it does. And we want to sum to the invalid number, and it will at least 2. So at least 2 numbers. Does that include 2? Does that mean 2 or more numbers, or does it mean more than 2 numbers? I'm guessing at least 2 means 2 is the smallest number that is valid here. So that should actually be called at least 2 numbers. That adds up to... so let's drop in another extension method here. Public static, and this is going to return a list of int64. Boom. This list int64 inputs. And what are we going to do? So... I'm thinking some beautifully elegant combination here of recursion and brute force. So our scenario is going to be, 1, is there always going to be something? Do we always have an input? So if we got a sequence of 3 numbers, let's look at my example on paper here for a second. So if we've got, say, this list of numbers, 3, 5, 7, 12, 16, 28, 42, and we are looking for, say, 12 plus 7 is 19. We're looking for 24. So what we want to do now, I think we want to kind of work this thing... no, it's actually easier than I think. So for every number, so we'll start by looking at 3, and we'll be like, all right, we got 3, let's look at 3 plus 5. What does that give us? 3 plus 5 equals 8. 8 plus 7 gives us 15. 15 plus 12 gives us 27. Too big, 3 is not allowed here. And that lends itself to, yeah, there is a recursive solution to this. Because what the recursive solution will allow us to do is to say, all right, well, 3 plus, actually, no, there's not, is there? We look at some index I. If I plus the next number in it is, so first of all, if I is greater than our target, we bail out. It can't be I. So I greater than t, bad, doesn't work. If I is less than t, then what we want to know is the next element in the list I plus 1 and t minus whatever that value was. Okay, that'll give us a recursive case on that. And if we run out of things, we want to bail out. So, recursion. Base case. So find contiguous list of at least 2 numbers that add up to this. So this thing is going to return a range. But we are going to want to put in a this input and then int starting index. Okay? You can have 2 indices, first and last. Sum the range from the first to the last and increase first if needle. So needle here, I'm guessing, Adam, is what we're looking for. Needle in a haystack kind of thing. Is that right? If needle is smaller than the sum, and increase last otherwise. So ding, ding. Not big enough, make it wider. Not big enough, make it wider. Not big enough, make it wider. Bring the code back. Thank you. Doom. There. So, sum, not big enough, make it wider. Not big enough, make it wider. Too big, bring the back in. Make it wider, bring the back in. That's nice. That is a nice algorithm, Adam. So, how do you implement it? How do you code it? So int starting index. If inputs dot skip first index dot take first final index minus first index dot sum and we need the target, don't we? Equals target. Then we want to return there, it's that. So var range equals that. Actually, let's call that window. Window's probably a better thing than range because it implies we're sliding the ends of it. So if window.sum equals target, return window. If we can just loop over this, can't we? It could be recursive. We could just do it in a loop. So let's, I'm going to try a loop approach first. And I'm going to say, so while first actually, while final index is less than inputs.length. Yep, that's fine. So if window.sum, that's that. Window equals the range. Var sum equals window.sum. Yeah, we're looping on it. 22 seconds ahead of you, Adam. Exactly 22, thanks to the wonders of the YouTube stream latency. Sum equals window.sum, and if sum equals target, return window. We found it. If sum is less than target, final index plus plus. If sum is greater than target, first index plus plus. Round and round and round we go. And I think it kind of feels intuitively like the mathematics of the thing means we'll never get a thing where our first index overtakes the final index. But I'm wondering what's going to happen there. That can be a, nope, that's fine, long target, yeah, that's alright, that's fine. When first becomes equal, yeah, so first becomes equal to last. That's the scenario we need to think about here. So, and this is actually going to return window.toList, isn't it? While final index is less than that. So if the first becomes equal to last, so this is when you say last, do we mean the end of the input range, or do we mean the end of the window? So we're gonna increase that. We're gonna increase that. Bring that in by 1, 2, 3. Interesting. So I'm gonna run this and see what happens, because that's just saying not all code paths return a value. So if we don't find anything, we get all the way through that, and we blow up. At that point, we probably just want to return. Well, nothing. It doesn't matter. It shouldn't happen, because the puzzle has told us that the solution we're looking for will do the thing. So we can return a new list of int 64, can't we? Right. Boom. Let's do that. So sequence equals number dot find a continuous sequence of at least 2 numbers that add up to that, and we don't need to specify those because we're not doing anything recursive. So int first index equals 0, int final index equals 1, because initially we're looking at the first 2 elements. Yeah. So let's see if I'm just going to put a thing in here that says at every step of that index, so if first index is greater than or equal to final index, debugger.break. So if this thing hits the debugger, then we're going to know we got to somewhere I wasn't expecting us to get to. There's our input.text. So let's just go back over. Again, consider the above example. Is that the same example? 35, 20, 15? 35, 20, 15, yes. In this list, adding up the numbers from 15 through 40 produces the number 127. So the solution to this one should be 62. So let's flip our input back to, we're going to uncomment that. Ooh. Ah, what? No. Come on. Thank you. Inputs that. Our window length is not important for this part of the puzzle, is it? Console.writeLine. No, it is important, because we need to find the invalid number in order to be able to find the sequence. So let's run that and boom, see what happens. It did indeed return a system.collections.generic.list of system.int64, which is maybe what we want. I don't know. Breakpoint. Boom. Let's have a look in the debugger, see what we got. We're expecting that sequence there to be a set of numbers, 15, 25, 47, and 40. And this thing over here said 15 through 40 produces the invalid number. Smallest and largest, sum those, producing 62. That indeed 15 plus smallest and largest, not the first and the last. That's why we check the requirements, friends. So var solution equals sequence.min plus sequence.max. Console.writeLine solution. Alright, why is that okay, that should be fine. That's nice. Alright, boom, run it. See what we get. Solution is 62, which is what the requirements say, 62. What is the encryption weakness in our Christmas encrusted... I just tried to say Christmas encrypted list and it came out as Christmas encrusted. Yeah, English language is hard and brain cannot mouth well internet words. Right, switch the input back to be our file.readAllText. That is gonna mask that. How are we feeling out there, friends? We optimistic about this? Do you think the solution is going to yield what we need? It didn't hit our... Well, it might land on our debugger there, or it might give us an answer out of the other side.
Multiple in, yeah, that's fine. All right, that doesn't matter. That doesn't matter. I'm gonna just do a. I'm gonna put a .toList on the end here so that it only enumerates that once. Otherwise, we're enumerating across the enumerable multiple times. Let's run that. See what we get. What are we thinking? We are on the debugger. Boom. What has happened when we get to the debugger here? First index is greater than final and is equal to final index. So we've immediately gone, oh no, hang on. At that point, I think we want to increment final index. That's my hunch. Because if we ever catch up with ourselves, well, let's just open the window by another notch. Debugger.break is, no, it does break the compiled exe. If you run a exe in, if you compile it in debug mode and you run it, it'll crash, but it'll pop up a thing going, hey, you need to attach a debugger here so I can break into it. I think if you compile code in release mode, debugger.break does nothing, but do not quote me on that. We can try that out another day. Let's have a look at what we got here. It's okay. So that's just 32 because I haven't cranked up the window size. 25 on that. Boom, run that. 2980044 is the yeah. You can clip me saying it and put it on the internet if you like, but anybody who is using clips on Twitch of me doing Advent of Code as their definitive reference for the .NET Common Language runtime, yeah. Best of luck to you, friends. You're going to clip that and edit that into it now, aren't you? Right, 2980044. Let's go over, take a look here, and boom! 1 gold star closer to saving your vacation. You have completed day 9. And that only took 47 minutes. That was pretty cool. I like that. That was fun. So, let's share that on Twitter and... Sweet. Right. Now, what I tend to do if we end a little bit early is I look at the code we got there, and I think, is this code that lends itself to being easily translated into Rockstar? Today's not, because we're using a lot of quite complicated linky stuff. I got these extension methods and, various bits and pieces that are working on there. Maybe part 1 could be Rockstarred. Should we have a go? Let's have a go. Let's see if we can do a code with Rockstar.com solve in part 1. What do we got here? Yeah. Thanks, dude. Yummy, courageous clam, Asian glow. Yeah, I'm sure that's absolutely just completely random and does not mean anything to anybody. Right, let's look at another one. What else have we got coming up? So, I got 11 minutes on this, then I got to go and do something else. But just maybe, 11 minutes time will be enough to have a little look at part 1 in the Rockstar programming language. So I'm going to grab that lot there. I'm going to uncomment that and copy that. And I am going to spin up the world's most powerful IDE, which is codewithrockstar.com. Try it. Here is our input. No, that is not good input. That is bad input. Give me a clean input, please. So there's that lot, there's that lot. Right, check the syntax with the thing first. So listen to the night. While the night ain't nothing, shout the night.
listen to the night, blank line, rock, boom, there we go. All right, that's our loop. That is reading in every number of the standard input. And we're looking for... this is where it's going to get just a little bit fiddly, because... okay, so now we got the night, shout the night, well, listen to the night, while the night ain't nothing. So the new array push operator that is in Rockstar here, I wonder if it's running in this implementation yet. While the night ain't nothing, I need to be able to push that into an array. So let's say the list is nothing. Listen to the night. Rock the list. So that turns the list from nothing into an array with nothing in it. Actually, just rock the list. That declares an empty element array. Rock the list with the night. Shout the night, listen to the night. So that should loop. That should put everything into an array syntax for us. Let me just shout the list here, see what we get at the far end of that. Boom. 20 elements in that list. While the list ain't nothing, roll the list into the element, shout the element, rock that, boom. Okay, cool, it's working. So rock and roll here are doing the job of push and pop. So if you're familiar with array-based stack modification stuff, I'm just going to put a thing on Twitter telling them that we're trying to do this live in Rockstar, and see if we get any other folks joining the stream. Anyone's curious, we're doing part 1 of day 9 in Rockstar. Right, hang on. Move that window over there. There's that, there's that, there's that. Move that window over there, whack that up. There's the screenshot. Let me grab one of those. Oh. No, deer in the headlights look. Big smile for the camera. Hey! God, I feel stupid doing that. There we go. Grab that, copy that, paste that onto the tweet. I have no idea how meta this is getting right now. Oh yeah, of course, and that is advent of code, but I figure people will figure that bit out for themselves. So, right, what do we got? Listen to the night. While the night ain't nothing, rock the list with the night, listen to the night. Shout the list. So what we got here is that can come out. That blank line there terminates that loop. So this makes it a little more obvious what it is we've actually got going on. Blank line terminates while loop, so that's fine. While the list ain't nothing, roll the list into the element, shout the element. That should give us, yeah, there is our set of inputs. That's printing out that whole thing there, which is kind of fun. That's working. So let's plug in Sunning. What is it that we need to do? We need to rock the list. That's fine. That's fine. That's fine. That's fine. So we need to look for it's all right. I'm gonna stick around a little longer. I can make up the time it took to do the little bit of social media publicity there. So shout the element. Blank line terminates the while loop. Now let's look back at that algorithm we had over here, because what we need to do is find 2 numbers from that list, and where was the find weirdness and is weird. So find weirdness is just going to enumerate across the whole lot. So let's just, so the syntax for doing an array enumeration here, the index is 0, while the index is weaker than the list, let the value be the list at the index, shout the value,
shout, yeah. Yep. Let the value be the list of the index. Build up the index. Blank line terminating loop. Let's rock that. Let's build the index up. Rock that. Interesting. That did not shout any yes, did it? And index 0. One index is weaker than the list. So what did we have on the list? We emptied the list. This thing here emptied the list out completely because the roll thing there is doing like a list pop on it every time. So let's run that one, rock that. 35, yeah, 20, yeah, okay. So that's how we loop across a list in Rockstar. So what we need to do now is for every number we want to so the preamble is going to be 5. So let the preamble, actually, the preamble is, we need a 5-letter word for this one. The preamble is weird. That'll do. And then later, once we've got it working, we replace all the sensible variable names with bits of rock and roll, and we throw out all of the comments and things so that it reads like a proper Rockstar program. The preamble is weird. The index is 0, while the index is weaker than the list. So let's start with let the index be the preamble with, well, it's +1. Let the index be the preamble, yeah, build the index up. That'll do. So the index is now the first element to look at. Okay. So then what we want to do is let the target be the list at the index. Let the first be the, so this is now we want to look at all the elements in that window. Let the first be, and the window is sliding, so, hey, loose. The preamble is metal. I like that. Yeah, that works. Cool. Thank you, CyberZ. So let the first be the index without the preamble. So that's going to do index. If the index is 6 minus 5, 6 minus 5 is going to be 1, 2, 3, 4, 5. So start off with index 5, 0, base 0, 1, 2, 3, 4 is our preamble, and 5 is our element. Increment that. Now that's 6. So now we got 1, 2, 3, 4, 5, and 6. Yeah, so the first will be the index without the preamble. Hey, CodeVox, welcome. How you doing? So we can actually do something a little bit. Build the index up is going to be fine. Let the first be the index without the preamble. Let the final be the index without 1. That should work. So I just want to, what I'm going to do is just build this thing up just enough that I can check the loop is going to give us the right things in each situation. So shout the index, shout the first, shout the final, let the index be the preamble, so that's all fine. The preamble is metal, let the index be the preamble. Build the index up. So we are starting there. So now while the index is weaker than the list, let the target be the list of the index. Let the target, and while loop. Yep, that's fine. I'm gonna stick that on something useful. We might need that in a minute. Let's rock that. Infinite loop. Why has we got an infinite loop? Because we are never building the index up. Yes. Boom. Rock that. Okay. So that is giving us, so looking at index 6 is going to go from 1 to 5. Looking at index 7 is going to go from 2 to 6. Look at 8 is going to go from 3 to 7.
Look at 9 is going from 4 to 8, 10 from 5 to 9. Okay, so we've got sliding window of 1, 2, 3, 4, 5 with the last element on it, and that loop is going to terminate. So what we need to do now is look at that whole chunk, listen to the night. Well, the night, yeah, that's fine. So shout the index, shout the first, shout the final. We need a loop inside a loop. So if there are any two numbers inside that window that add up to the target, then this number is not this is gnarly. If there's any two numbers inside the loop which do not inside the window which do not add up to the target we're looking for, then this is not the target we're looking for. We need to increment and build the index up to the next one. So the target is the list at the index. Let the first be the index for the finally the index for that one. So then we want to say, how do we build this nested list syntax? So let the final be the index without 1. So there's the first. Let the slider be the first with 1. So that's our second element on the index. So if the while the slider is weaker than the final, if the list at the first with the list at the slider is the target, shout, no, we found a sum with the list at the first with that and with the list at the target. So if the slider is, yep, that's fine. Take it to the top because we want to move on to the next element in the loop here. Do we? I'm not entirely sure. So if the list is the first with the sum and the list and the slider is the target, else. So else is a Rockstar thing we need to fix because no one ever shouts else in a song. Else shout not a sum this time. Build up the slider. So let the slider. Well, the slider. So this is called. Let's just call this one loop 1, and that is gonna terminate loop 1. These comments, by the way, if you've not seen Rockstar before, the bracket sign, these are comments. It's actually the blank line here, the line with no statement on it, that marks the end of the while loop. So while loops as far as there. While the slider is weaker than the final, build up the slider. That's going to do that. And if I rock that, what am I going to get? Shout, no, we found a sum. Oh, and then I have a parse error. Why do I have a parse error there? It's expecting... interesting. But quote found. Shout, no, we found a sum with the list at the first, with the and with the list at the target. That shouldn't be there. Yeah, that's fine. Boom. There we go. Build up the slider should be build the slider up. Boom. Let's run that again. Not a sum this time. That's stuck in an infinite loop. It's looping round and round and round and round and round. Build the slider up while the slider is weaker than the final. So at some point, let's shout the slider, shout the final, check that's incrementing properly. 2535, 2545, 2535. Okay, so the reason why that's blowing up is that it is just looping round and round and round every time. Build a slider up, terminates that loop. Now at this point we need to... interesting, why is that looping? How many loops we got here?
So we've got, that's our initialization. The preamble is metal, let the index be the preamble, build the index up while the index is weaker than the list. So that's loop, actually that's loop 1, that's loop 2, that terminates loop 2, that terminates loop 1. So we got nested loops, but one of those loops does not have an escape condition in it. I need to terminate the block. So that build, the slider up, is only happening in the else condition there. If that's if block 3, shout that. So that terminates block 3. Yep, that should work fine. Although I say that should work fine, like I have the faintest idea until I actually run the thing. Hey, from Mexico City. How you doing, Carlos? Welcome to the stream. 2525252525. No, I've put the that in the wrong place. Interesting. That's just 252525 every time. Why is that not behaving properly? Shout the slider, shout the final, shout, no, we found a sum else, shout, not a sum this time. Terminate the block, build the slider up, terminate the loop. Shout slider with the slider. Slider is 2, slider is 2, slider is 2. Slider is never incrementing. Why not? Well, the slider is weaker than the final. Shout slider, that's fine. Shout the final. If, shout that. Else, do that. Terminate the if statement. Let me just throw in a couple of random new lines there. That's weird. The slider is never incrementing. The comment does make the line empty. That ends the block. I'm going to take out that not a sum this time. I might just be making a mistake here with the way the block syntax is working. Shout no, we found a sum. So that if there should have an end if. That should be terminating on that. Slider 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4. Okay, so that's now looping and incrementing. Shout the slider, so that keeps dropping us back to here. Let the slider be the first with 1. Build the slider up, shout the slider, that's fine. If we get to here, we want to shout the index. What is the index doing? That's probably terminating too many loops. Boom! It's all about getting the right number of new lines in exactly the right order. So we now have slider 2, 3, 5, slider 3, 4, slider 4, 5, 5, 6, 5, so what are we outputting in all of these cases? That's the slider. Shout the final. If the list at the first with the list at the slider is the target, shout no, we found a sum. Do something. Else shout YOLO. Just see if that's going to work. That's weird. That is weird. I think there may be a bug in the parsing behavior there that is causing those loops not to obey the else clause properly. If the list of the list is shout that, else shout YOLO, end if. Right, take that out, take that out. That's end if. This has given us a terminating loop. This is good, this is correct. So, build the index up. The index is now that. That's that, that's that, that's that. Well, the slider is weaker than the final. Shout slider, that's the slider. Shout the final. If the slider gets to the end of that loop, and we have not found a sum, then what we need to do, is there a missing construct for ending an else? Quite possibly. Let me just do a quick thing here. So you're going to get a scene behind into the Rockstar lab where the magic happens here.
CD project, CD rockstar, Spark, boom, run that. So this is a little tool that I use when I'm hacking on the Rockstar language grammar and stuff. Tools, peg, that's the current language grammar. That is the program. And interestingly, trying to parse that program has just crashed my abstract syntax tree visualizer. That's a lot of fun. Let's try that again. Localhost 8080, boom, there we go. Tools, peg.js, thank you very much. Parser built successfully. There is my program. So there's our work in progress. Let's grab that first chunk there. I don't think we're going to get a working solution in the time we have available today, folks, but you are getting a little bit of an insight into how I hack on this kind of stuff. There are no stages, CyberZ. Okay, so this is the abstract syntax. This is the parse tree for that. So rock the list is saying, take the variable, the list, pass that to the nList processor, which turns things into lists. Take the listen to standard input and put that into the night, which is going to populate that. There's the while loop. That's all fine. There's the condition. There's the consequent. That's fine. So let me drop in a couple more lines here. That gets us a bunch of... The preamble is metal. So the preamble is metal. Assign the preamble to 5 index null because that's not indexed. Let me just move this. I just realized that my head is kind of covering up the syntax tree that you're looking at here. And I can probably make all that a little bigger. Yep, okay, so we got a whole bunch of syntax. That's all good so far. There will be stages again. Oh yes, there will, definitely. So while the slider is weaker than the final, shout slider, shout the final, S, terminate loop 2. So let me see what we got if I drop that lot in. Now, like I said, last time I tried this, it crashed the parse tree generator. What do I get if I drop that in there? Boom. And yeah, there is something in this that is crashing that parser, which is not expected behavior. Boom. So you can see, tell my workflow for this language is incredibly highly optimized. There are beers in bars now, just no access for people. You can have beer as long as you have a substantial meal with it with a member of your own household. Right. Let's do this in bits. So let the target, let the thing. Let's take out that inner loop there. Take out the if, take out shout the slider, shout the slider, shout the index. So I'm going to grab that lot. I'm going to put that lot over here in Notepad. There we go. I'm going to grab this slot. And I'm going to drop that. Actually, that whole program I'm going to drop in here and see what syntax tree we get out of it. Input parsed successfully. All right, cool. So that's giving us a valid set of loops. Okay. Assign the slider, the slider, the slider, and we've got a while loop with a condition. The index is less than left. If the index is less than the list, yeah, LT comparator. Then do this lot. So what do I get out of that now? If I grab this little chunk of code here. And so let's just try the simplest possible thing. Well, the slider is weaker than the loop. So we'll grab that, build the slider up, and then terminate the nested loop. So let's see what we get by dropping that into the middle of this loop here. Let the slider be the first with 1. Shadow index the first to final. Do that. That should parse okay. We've now got a while loop, and the consequent for that is a list assignment and an assignment and an assignment and a while loop. So that's cool. We've got a loop inside the loop. That's working. And what we were
looking for was the if and the end if inside that one. So while the slider is weaker than the final, yep, that's fine. If the slider is 5, shout yes, else. Yeah. Boom. Okay. That says it's passed it successfully. There's the assignment, there's all that, there's that, there's that, there's that, there's that. And let's have a look for that output statement. Yeah. So we've got a conditional here. That's the condition, which is a comparison on equality between the slider and the number 5. And if the output, so the consequent is you do this if it's true, the alternate is you do this if it's false. Consequent output string, yes. Output alternate string, no. So that should all be fine. So I'm guessing that if the list at the first with the list at the slider is the target, let's see what we get if we put that in there. So that's... yeah, boom. All right. So I think we have found a bug in Rockstar, my friends. And I think the reason why the bug is happening is probably that the... yeah, wait for that. This little chunk of syntax here at the slider, if the list at the first with the list at the slider is the target, is probably ambiguous between this expression equaling the target or the slider is the target being evaluated as a equality, and yeah, there's some syntax in there that doesn't work. I'm going to grab a screenshot of that. And I'm going to file a GitHub issue, and then I'm going to bid you all good day, and I'm going to beam myself to Munich to talk about computational creativity and algorithmic movie special effects. There we go, that's fine. Copy that lot, boom, and github.com/rockstarlang/rockstar issues. The world's... oh yeah, we'll raid somebody. Yeah, of course there'll be a raid, definitely a raid. But then I'm gonna leave you all to enjoy yourselves, and I'm gonna duck out. So parser bug. So there's that, and let me just grab the boom. All right, friends. Let's go raid somebody. Who do we want to raid? Let me have a quick look and see who's online. Ooh, the Live Coders team. Let's see who's on from the Live Coders team. I Develop Things is on. Code Rushed is on. Let's raid Code Rushed. Code Rushed is nice. We like Code Rushed.
Let me fire it up. So, raid code rushed. Thank you, friends. That's lots of fun. By the way, if any of you are looking for stuff to appear on YouTube a couple of days later, day 7 has gone missing, and I have no idea why. So I'm going to see if it shows up, and I'm also going to try and get actual recordings of these, because from tomorrow I'm going to be streaming just on Twitch, only Twitch, and then I'll be uploading the recordings to YouTube afterwards. Right, we're going to go and raid Code Rushed, who has got some really cool overlay graphics and stuff. Thanks for tuning in, folks. That was a lot of fun. I got Rockstar bugs to fix, and talks to do, and actual work to do. Take it easy, gang. See you soon. There will be a raid. That's my raid music. Yeah, what kind of raid? Raid 1, raid 2, raid 5, raid 10. Let's raid. See you later.